Good morning, my dear students. In this particular video presentation, again, we'll discuss some more problems meant for competitive examinations. We'll discuss certain rules on inverse trigonometric functions and its application in another problems. Just see here. Show that tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy xy less than 1. This condition is a must. Just remember carefully. The proof goes like this. Let tan inverse x is equal to a, tan inverse y is equal to b, theta 1, theta 2, alpha, beta, either way you can take. Therefore, x becomes tan a and y becomes tan b. Let me try to simplify tan a plus b. I mean to say tan a plus tan b divided by 1 minus tan a tan b, which implies tan a plus b to be is equal to x plus y by 1 minus xy, which will imply you a plus b is equal to tan inverse x plus y by 1 minus xy, which will automatically imply you tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy. Let me just recall the proof once again. I take tan inverse x as a, tan inverse y as b. X becomes tan a, y becomes tan b. Let me try to simplify tan a plus b. Tan a plus tan b by 1 minus tan a tan b. Tan a plus b is x plus y by 1 minus xy because of these two results. These two, if you want, you can write it as 1 and 2. Now for taking tan to the other side, a plus b becomes tan inverse this much. Therefore a can be replaced by tan inverse x, b can be replaced by tan inverse y. Therefore tan inverse x plus tan inverse y will be is equal to tan inverse x plus y by 1 minus xy, and the condition is meaningful whenever xy less than 1. Remember carefully. Then prove that tan inverse x plus cot inverse x is equal to pi by 2 x element of R. Let tan inverse x equal to a, the same way I'll take. Therefore, x equal to tan a, which implies x is equal to cot pi by 2 minus a. Even in lower classes, students might have learnt tan 90 degrees minus theta is cot theta, cot 90 degrees minus theta is tan theta. But degrees is written in terms of radian measure as pi by 2, which implies cot inverse x equal to pi by 2 minus a. Sorry, here it is a, pi by 2 minus a. I wrote it as simply x, sorry. Cot pi by 2 minus a here. Okay, this is pi by 2 minus a, which implies a plus cot inverse x, a plus cot inverse x equal to pi by 2. Therefore, tan inverse x plus cot inverse x gets reduced to pi by 2. Tan inverse x plus cot inverse x gets reduced to pi by 2, which implies tan inverse x plus cot inverse x gets reduced to pi by 2. I repeat, take tan inverse x equal to a, x becomes tan a, can also be written as cot pi by 2 minus a. Bringing this to the other side, cot inverse x pi by 2 minus a plus cot inverse x pi by 2, that's why tan inverse x plus cot inverse x gets reduced to pi by 2. Then there is one more result. Show that cot inverse x is tan inverse 1 by x if x greater than 0. Cot inverse x equal to tan inverse 1 by x. X greater than 0. There is another result. Cot inverse x is equal to tan inverse 1 by x, x greater than 0. Put cot inverse x equal to theta, x equal to cot theta. Now tan inverse 1 by x is equal to tan inverse 1 by cot theta is equal to tan inverse tan theta, which is theta theta is nothing but cot inverse x. Sorry, theta is nothing but cot inverse x. This is my RHS. Sorry, LHS. This is my LHS. This is my RHS. Let me repeat. Cot inverse x equal to theta. X is cot theta. Let me start with RHS. Tan inverse 1 by x. Tan inverse 1 by cot theta. Tan inverse tan theta. Tan inverse tan theta is theta. Theta is replaced by cot inverse x. Therefore, tan inverse 1 by x is nothing but cot inverse x. Therefore, we have seen three different results. Tan inverse x plus tan inverse y is tan inverse x plus y 1 minus xy if xy less than 1. And tan inverse x plus cot inverse x is pi by 2. The second result we have seen. And third result is cot inverse x is tan inverse 1 by x. Cot inverse x is tan inverse 1 by x. Now, using these results, there is a simple proof. Prove that tan inverse 1 plus tan inverse 2 plus tan inverse 3 is equal to pi. Listen carefully. I can't group the first and second because 1 into 2 is greater than 1. I can't group the second and third. 2 into 3 is greater than 1. I can't group first and third. 1 into 3 is also greater than 1. Therefore, just see what happens. Tan inverse 1 plus tan inverse 2 plus tan inverse 3. Here I just replace this pi by 4. Here I'll write it as pi by 2 minus cot inverse x plus pi by 2 minus cot inverse 3. Just now we have seen pi by tan inverse x plus cot inverse x pi by 2 we have seen. Therefore, tan inverse 2 can be written as pi by 2 minus cot inverse 2. Sorry. Now, let me group the constants over here. Minus, I'll write cot inverse 2 plus cot inverse 3 together by taking minus as common. Here LCM is 4. Sorry, LCM is 4. Pi plus 2 pi plus 2 pi minus, this can be written as tan inverse half plus tan inverse 1 by 3. Just because the rule which you have seen now, cot inverse x is tan inverse 1 by x. Now this is 5 pi by 4. Now apply the rule 1 by 2 plus 1 by 3 by 1 minus 1 by 2 into 1 by 3. The first result which you have seen just now, tan inverse x plus tan inverse y is tan inverse x plus y by 1 minus xy. Here the product 1 by 2. Here it is possible because half into 1 by 2 and 1 by 3 is less than 1. Therefore, the application is correct. Therefore, this is equal to 5 pi by 4 minus tan inverse. Take LCM. I get 5 by 6 by 5 by 6 I have. Therefore, this is reduced to 5 pi by 4 minus tan inverse 1. 5 pi by 4 minus pi by 4, which is 4 pi by 4, which is pi. This is my right hand side. Now for tan inverse 1 plus tan inverse 2 plus tan inverse 3 becomes pi. Let me just repeat the whole process. I can't group these two because 1 into 2 is greater than 1. I can't group these two. 2 into 3 is greater than 1. I can't group these two. 1 into 3 is greater than 1. Now for this tan inverse 1, I write it as pi by 4. Tan pi by 4 is 1. I'll write this as pi by 2 minus cot inverse 2. I write this pi by 2 minus cot inverse 3 using tan inverse x plus cot inverse x is pi by 2. I'll group the constants pi by 4 plus pi by 2 plus pi by 2 minus in bracket cot inverse 2 plus cot inverse 3. LCM is 4. Pi plus 2 pi plus 2 pi, it gets reduced to 5 pi by 4. Here this is tan inverse half plus tan inverse 1 by 3 because cot inverse x is tan inverse 1 by x. Apply the formula tan inverse x plus tan inverse y is tan inverse x plus y by 1 minus xy provided xy less than 1. Here x is 1 by 2, y is 1 by 3. After taking LCM, this is reduced to 5 by 6. This is also 5 by 6. Tan inverse 1 is reduced to pi by 4. 5 pi minus pi is 4 pi. 4 pi by 4 becomes pi. Therefore, tan inverse 1 plus tan inverse 2 plus tan inverse 3 gets reduced to pi. The rest of the things will continue in the next video. Thank you students for patient watching.